let's talk about objects, classes objects. So class, in general, in object-oriented programming, it's what we call templates, or generic speaking. You want to make an analogy. Classes kind of like your blueprint, and object is a three-dimensional house that you built off of a blueprint, in a sense of a term. So in general, objects take up memory, and classes don't. Classes typically the static ideas where programmers insert informations about the object and also behavior about the object. So information is what we're talking about. Information is more about the properties that describe what the object is. So sometimes people talk about attributes, objects, object attributes, object properties. They're synonymous. So that's the information. These are typically nouns. So if you're to, let's say, build off of a vehicle class and try to instantiate a vehicle class into an object, the properties or the information or attributes associated with the vehicle object could be the color of the vehicle, for example, or the number of wheels this vehicle has. So these are the nouns we're talking about. These are the informations about that. And the other part of so that would be kind of the information part. And then there's a whole bunch of other behavior associated with this, this object. And these things are what we call methods. So when we're talking about these behaviors in the context of a class or object, these behaviors are methods, and they're not functions. Methods and functions are different. Methods are part of a class. So at runtime, they become behavior inside the object. Okay, so they're basically verbs specifying the responsibilities that the object does. So there you go. An object typically encapsulates both informations and behavior associated with it. So in general, when we build softwares, we go through we go through software designs, and we build these hypothetical objects, mimicking real world entities. So like, for example, if we were to build an ATM for a bank, then that software application could consist of multiple parts inside an ATM machine, representing what the ATM does, the checking accounts for the customers, the users who will use the ATM machines, and various different accounts associated with the users. And so that is how objects are typically used. So we want to make sure that these real world representations make sense, and therein lies the use of the proper use of information and behavior. Okay, so that's what objects do in real time. Just remember that objects take up memory at runtime. So objects are self-contained and therefore easy to implement, modify, and test for correctnesses and reuse. So when we're talking about self-contained objects, we're going into the core of OOP. So there's a couple of cores here. You might have gone through this in your intro Java, but when we're talking about object-oriented programming OOP, the first one is what we call encapsulations. So this is similar to what we talked about, data structure, encapsulate informations and abstract informations away using interfaces, right? But here, the encapsulation is self-contained. So for example, objects have the ability to hide information through use of various different keywords. So we have private information, we have public information, we can also have protected information. So this is encapsulations. And object, of course, they also inherit from each other, meaning you don't have to code up or duplicate a large swath of code for a specific, let's say, software applications. If you can rearrange these objects, and we're talking about this is in subsequent sections, if you can rearrange these objects in a meaningful way to inherit from one to the other, and then that would that would tremendously help reduce the amount of duplicate informations and to help you write more efficient code that runs faster. So the second one is inherited, and the third one is what we call polymorphism. So we'll touch base on some of these in this chapters from time to time, but that's what objects are self-contained really means, because it makes use of these various different OOP principles to organize themselves and be able to transact information efficiently. So let's move on to the next page. So now we're talking about classes and objects. An object is an instantiate of the class. So just wanted to make sure everybody understand. Instantiation means dynamically allocating memory at runtime, okay? Or statically allocating memory at runtime. So just wanted to be super clear that you guys understand the principle behind this is, and if you're looking at this entire cloud, which is drawn here in red, assuming this is your 32 gigabytes of memory at runtime, a small portion of that memory space in this case is what I'm drawing here, is this entire box. This area is what we call stack, okay? And the rest of it is what we call heap. So let me just illustrate this. So this is a stack, and the rest of it is called heap. So when we say an object is instantiated at runtime, either an object comes out of the stack or comes out of the heap. In Java, you dynamically allocate an object to instantiate it. So what does that mean? An object, when instantiated, occupies a certain amount of memory space. And that is what instantiation means. When a certain space is allocated for the object also has what's called a memory address associated with it. So for example, when you're dynamically allocating objects via this, let's say you have a date class. This date is the Java util date, and doing this using your default constructor that comes with date to create this object D. So what this is doing is that you're dynamically allocating a space inside this memory cloud, and this memory space may be sitting somewhere here, this little blob right there. And there's a memory address associated with it. And for the sake of illustration, let's just say that memory address is FA1 in hexadecimal representations. And the object is instantiated with that memory address. And when you start making use of that variable, that variable gets passed from one section of the code to the other through reference. So what you're doing is you're creating a reference of that class, and that class is being passed by reference. And that is how Java really does, making use of these references at runtime. These references have some sort of memory associated with them. They're associating their object at the memory address where they're created. And all of the informations about, information's attributes, informations, and behavior informations are encapsulated in this memory space for that object. A class definition includes variables and methods. And so we talked about this, right? A class is a blueprint that has both the informations and data, informations and behavior. So it's, in one textbook you see data, actions, and in another textbook you see properties and methods or member variables for these actions, and data being properties or attributes. So here's an illustration of a date class. Let's take a closer look at it. So this is a date representation, a date class from your textbook. And you may, for the purpose of this illustration, you may just ignore this this package. This is the package from the author's work implementation of date. So aside from that, you have a public class, and this public class has a whole bunch of information or attributes, and these attributes are year, month, and date. So this date class represents the year, month, and date of a date object. It also has a public static final in. So what this is this is a constant. So Java doesn't have a const password. but it uses a combination of different keywords put together to make a constant: public, static, final, in. So public means everybody has access to it. Static means that there's only one instance throughout the entire life cycle of the code. Final means this cannot be modified. Integer means that this is an integer. This is an integer data type, and this one has a value this. And since you're initializing this constant with this value, this min year stays true throughout the entire life cycle of your code here. Now, that min year would also be available as soon as this class is instantiated. So this is just a blueprint, and it's showing you that there is a public constructor, and this public constructor takes these arguments at runtime, and it basically dynamically assign the value of what gets passed in these arguments into month, days, and year variables respectively. And the reason why this is protected is because now when a variable is protected, it has both package and subclass visibility, meaning if somebody were to inherit date as a subclass, that subclass would have access to this year, month, and date. But more so, this protected allows anything sitting inside this package that is in CH01 or chapter 1 .date package, any classes within it to have visibility into year, month, and day. So it is very possible that in the date package that there's other utility date objects that may be using that may make use of this date object. So the reason why year, month, and days are they come with protected variables here. And then you have a whole bunch of action classes or methods associated. So these are, by the way, not functions. Okay, so functions are standalone, modules that takes a set of inputs and gives outputs. But because these functions, quote unquote functions, are sitting inside a class, they're of the class, they're actually term methods. So there's a difference between that. So if you don't know what it is, you can either ask me later on or Google this. Method is not the same as a function. All right, so in this case, these are methods. All right, and the last one is there is a toString function. So this toString function is a overwritten function from the Java util Java Lang object. So everything in Java is an offspring of what we call Java Lang object. So Java Lang object has a generic toString. So basically, every object that you create in Java has a toString. So this toString, if you go on going to the Java API, you'll see it. It's responsible for outputting a specific description about the object. So there is a unique ID associated with each of these objects, and typically they specify the name of the class that represents this object. But what we are doing here is we're overriding that toString with a custom return of a string. And this custom return of the string says the month, day, and year with a /. Okay, so this is a quick overview of the Java date class. Actually, this date is author's custom implementation of the date object. This is not a Java date objects here per se. Let's move on. So this is a quick overview of the various Java access control. So you have public, protected, private, and package. Now we're not using package in this class. The reason is very simple. If you have a package that is only unique to your computer, your setup, your IDE, your code is not going to compile on my machine. I won't be able to grade it. So you're not going to do that. But you should be familiar with these keywords. So public basically means that if you have something that's declared as a public, within the class, outside of the class, everybody inside the package, outside the package could see it. When something is protected, you would have, first of all, package access and within the class. So within the class basically means that you can have inheritance structures where a subclass would have access to the protected variables inside the superclass as well. So that is protected, generally speaking. If something is private, then only the class itself would have access to that variable. This would include, so this means that if you were to instantiate a copy of the class, so this object would not have access basically to its own private information. So that becomes an issue. Therefore, private is the ultimate security measures that you want to use private exclusively for protecting information that you do not want going outside of the class. So that's a really, really quick overview, high-level overview of Java control modifiers. Let's move on to the next one. Oh, by the way, if any of you are still kind of fuzzy about these things, make sure you pick up a Java textbook and whichever textbooks that you used before, and just do a fresher, just to freshen up your memory and make sure that you understand these things. This is our very, very high level overview of Java before we start the data structure course. Okay. All right. The unified method, user driven. So we're going to bypass this part and then kind of illustrate what this class diagram for date class is. So what you're looking at here is is what we call class diagram. So this class diagram is probably one of the most famous representation means in what's called UML. Okay. Universal Markup Language. So this UML is a protocol or language for developers to describe, what they have in mind when they design a software system. And one of the most fundamental diagrams that you see in UML or you come across is what we call class diagram. And UML also has something like sequence diagram, components diagram, user diagram, interaction diagram. There's a lot of diagrams out there that describes various different aspects of your software system. So what you're looking at is a class diagram called date. And this date has basically all of the information or attributes sitting on top. And there is this delineations here that separates all of the info. Let me type this in. This is the info, right? I'm just going back what they were saying earlier. So these are the properties from those of behaviors. So here are the methods, right? So these are the behaviors part. All right, so you have on top properties and on the bottom behaviors. These plus signs means that these are public. And if there's the minus sign there, that means this is private. So there's nothing private about these. These are all public methods here. And these are the protected informations that we pull off of the date, as well as your constant. So there are specific conventions that is used in UML tool sets. As a software developers, you'll go through a lot of these things in software architecture class, but not in this course. So yeah, I mean, you can see that these are the argument. Now these are the parameters and the types separated by the parameter name, and as well the type associated with the parameters separated by a colon. So this is if you guys ever did Golang, this is very similar to Go syntax. Anyway, but this is the UML diagram for date class. Let's move on to the next one. Okay, so in the previous slide, we had date class diagram. And this is kind of like object. Yeah, this is the object diagrams where you have multiple copies of your date, and depends on, the argument that you specify to specify the year, month, and date for that object, for that date object. You have various different. You have actually, for the class, I'm sorry, then you have various different date instances. Every single one of these instances sits at various different memory locations here. And this is how you kind of represent the, how objects are interrelated with each other in this sort of visualizations here. Okay, let's move on to the next one. All right, so we talked about classes. We also talked about objects. So let's talk about applications. So application is a collection of these objects. So in a object-oriented applications, you have these objects, interrelated with each other. They're working with each other. They're communicating and transacting information with each other. They're sending each other messages. So sending each other's messages is a very interesting idea. And this is, if you ever taken Ruby on Rails, the Rubyist, when they said, instead of saying this object calls the object's function or method, they'll say this object sending information to a message to another object. So sending a message basically means invoking the object method. So this is akin to having these objects, communicating with each other through methods. So you can, if you know the handle for this object, let's say this object is A and this object is B. If A has access to B, and assuming that method is public or protected in a sense, if A and B are both inside the same package, then A can call upon B's methods. And that is the same as saying A is sending a message to B, and that message is the name of the method inside B. Okay, I hope this makes sense. But anyhow, the point of this is that inside the application you have tons of these message objects. You can have hundreds of these objects. They all interrelated in some shapes or forms. In software architecture, we describe when an object is an offspring or subclass of another. This is what we call is-a relationship, where the parent is on top here and then the subclass, okay, is on the bottom. And then you have this open arrows that represents the inherit relationship. And this relationship is what we call is a relationship, okay? Is a relationship. S is a P, right? Subclass is a parent. So that is inheritance, but also inside software architecture, we talked about compositions and association. So that's what we call has a relationship. So it is very possible that this S also has, in this case, this is a open arrow. So this is has a relationship to maybe another object called C, okay? And you can have cardinalities here specifying that this is one S to many, many C's. So you can have extras over here. So this is what we call has a relationship. Has a relationship. Has a relationship could be extras to extras, meaning multiple to multiple. It could be 1 to 0, 1 to many, or many to many, okay? So in a software application, you have both is a relationship and has a relationship. Has a relationship typically specifies either composition or aggregations. So what does that mean? All of these means that you have lots of these objects and they're associated by different type of relationships. And this relationship define what a software application is. So for example, using our date class to solve the problem calculating the number of days between the 2 days, in the next 3 slides, we're going to illustrate how this application kind of works with each other using this date objects and many, many other objects that you can create off of this too. Okay, so let's move on to the next page. This is the dates between design. Actually, you know what? I don't think I wanted to go through these because right now, I think it's sufficient to understand, just how object-oriented programming works in a general sense. And you guys also had other quizzes to kind of help you to assess, where you are in your Java knowledge. If you find any of these foreign to you, my advice for you is just to make sure that you refresh these topics that we just discussed. Before you really start digging into the data structures, because these things will be kind of a prerequisite to the data structure using Java. So what you're looking at here is a very simple console application. It's called days between. So you have a public class days between that has a point of entry main. It's basically asking, so system.in allows the software programs to start listening for any inputs coming from the users. So the user input in this case is your keyboard, keystrokes. If you type in letter A on your keyboard, it goes into the system in. So this system in picks up the cues from your keyboard input devices. Your system in can also be in, depends on which libraries you're using. Could also be your audio cue, from your speakerphone and things like that. But system in this case is coming from your keyboard. And then you're attaching it to your scanner. So this scanner is the one that is responsible for like picking up your the key informations that you just typed into the buffer. And then you can call or send a message to scans next in, right? Or invoke, right? Sending a message is the same as calling, is saying that you're invoking a method on this object. So this method is called next in. So this allows you to basically enter something, and then you can kind of piecemeal by parsing or tokenizing these integers that you just enter. And these integers are delimited by one too many spaces. So just to make sure that when you enter something that they're delimited by spaces. So you can pick these up one at a time. And then what you do is once you have information about month, date, and year, and notice that there's no exceptions here. So you gotta make sure that you enter just the integer and not A, B, and C or X, Y, Z, because this will then generate some sort of exceptions, and that's gonna take your program out of the commissions. So at the end, you're creating a new date object based on the month, day, and year that you are able to get. So the software application basically kicks off the entire mechanisms from this point on. So now that you have this date one in mind, I think the next slide shows another one being created, day two, D2 right here. So let's take a look at what this is. So you had day one from the previous one. Let's take a look at this one. This one is asking you to enter the second date, and you're doing the same thing. So you can have date D1 and D2, and basically they be of the same on different days or maybe different years. So what this application is doing is checking to see if this date is greater than or less than the minimum year that you just entered, that you specify inside the application. So remember that was a constant, right? And depends on the date that you just enter. If this is the OR situation, if any of these is true, then you want to print out you enter a pre-modern date. Otherwise, this is going to print out both D1 and D2 respectively. And then the computation of the date differences is being done by math.app. So math is a libraries in Java, and it's a class. .abs. So you're sending a message to this absolute function, okay, or you're invoking this method inside this class called math by giving it your Lineum calendar differences here. And so you're taking the absolute, which means there's no negative here. The difference is positive, right? Positive delta right here. One thing to of note is that your ABS is a static. So this means that you don't have to instantiate a copy of your math before using the ABS function. So when something is static, we call it function. So this ABS is, technically you can call it a member function of math, but because this is static, this is you're invoking a function, and this function is math.abs, kind of, okay? So like I said, when something is static, in this case, this function is static, it makes this function to be universally accessible throughout the entire lifetime of your software applications. So anybody who has access to your date package and whatnot can also make use of math.abs. Okay, so that is a quick overview of the date